Hi, today we're going to be working on Lesson 5, Session 3. We're going to be using estimation and area models to divide. We've been working on dividing using area models, and we're going to continue that work today. And then we're also going to learn how to use the partial quotient method to divide. I think that you'll see the connection to them both really well. So we're going to go ahead and we'll be working in our Ready Math workbook, pages 87 through 90. So go ahead and take out your Ready Math workbook and turn to page 87. So as we always do, we're going to go ahead and read the problem, and then we're going to ask ourselves our three questions. What is the problem about? What are we trying to find out? And what information is important? So let's read the problem first. A factory produces 768 buses and puts them into 24 buildings. Each building has the same number of buses. How many buses are in each building? Estimate and then solve. So they want us to first estimate and then solve. So what are those three questions we need to ask ourselves? First of all, what is this problem about? This problem is about buses being put into buildings. And we don't know how many of those buses need to go in each building. So what are we trying to solve? How many buses are in each building? And then our important information, we know that there are 768 buses. There are 24 buildings. We also know that they want us to estimate and then solve it for real. So now we have all the information that we need to go ahead and do our work. So if we were going to estimate first, if we could look at this and go, okay, well, 768 is close to 750. And then 24 is close to 25. So we're going to divide 750 divided by 25. Then we need to think, okay, about how many times can 25 go into 750? Well, I know that 25 times 4 equals 100. So I know that it can go in at least, it definitely go in 4 times. But then if I'm trying to get up to 700, well, I know that 4 times 7 is 28. So I bet that 25 times 28 would equal 700. And then how many more to get to 50? Well, 25 times 2 equals 50. So that would give us our 750. So about 30 buildings. Now, if you didn't get that, that is a-okay. But this just kind of gives us an idea of how where our answer should be, how close it should be. So now we're actually going to solve it, and we're going to solve it using an area model. So remember that we draw our first rectangle, and then we draw our second rectangle. We may also, I would say, are probably going to use a multiples of 10. So go ahead and make yourself a multiples of 10 chart. I don't know how many we're going to need. All right, so our problem is, what is 768 divided by 24? So 24 is going to be our multiple, and then we have 10, 20, 30, 40, 50, and 60 if we need to get up that high. But based off of what we estimated, we know it's going to be somewhere around 30. Then we can go ahead and fill out the rest of our area model. So our dividend, the number that we're dividing, goes into the middle of the area model. Our divisor goes on the outside, and then our answer or our quotient is going to be at the top, but we don't know what that is just yet. So now we're going to take this area model and we're going to break it up into partial quotients. So on the outside, we still keep our divisor on the outside. And then we're going to break this apart into two rectangles. The first, we'll put our whole dividend into our first rectangle. And then the first thing we're going to do is we're going to find out how many times does 24 go into 768 using multiples of 10. So remember, you're going to stop me when we go over 768. So 24 times 10 is 240. 24 times 20 is 480. 24 times 30 is 720. 24 times 40 is 960. Oh my goodness, hopefully you told me to stop. Now, we are going, because we've gone over. And the way that I went up each time, we're skip counting by plus 240 each time. So that's how we get to the next number. All right, so we know that the highest number that 24 can go into 768 without going over is 720. So we're going to put that 720 right here. And then we're going to take our 30, and that is our first partial quotient. The 30 goes up there. The way we did that is we did 24 times 30 equals, and that equals that 760. Then we're going to subtract and get our difference of 48, and then that remainder is going to go into our next rectangle to become our next partial quotient. So we put the 48 up top, and now we're going to say, how many times does 24 go into 48? Well, I know that 24 plus 24 is 48. So I know it can go in 2 times. So I'm going to put the 2 up top for our next partial quotient. And then 2 times 24, I'll write that right here. 24 times 2 equals 48. And then when I subtract, I have no remainder. So these, when we add these together, that gives us our final quotient. So 32 buses in each building. So when we solved it, we got that there were 32 buses in each building. Was our estimate close? Yeah, it was definitely close. If we had said about 30 buildings, we wouldn't have had enough buildings, but that's okay because we would have been close. So that is how you solve a division problem using an area model with a multiples of 10 chart. Don't worry, we'll be practicing that more if that didn't make any sense. We're going to go ahead and move now to page 88. Now on page 88, we're going to be continuing to practice what we just did. So I actually just showed you how to do everything that this page shares with you. So you're already ahead of the game. So in the Model It, this is talking about estimation. So you can use the relationship between multiplication and division to estimate the quotient. So 768 divided by 24 is the same as 24 times whatever that number is equals 768. So you can multiply 24 by multiples of 10 to estimate the quotient you get. Can organize and then you can organize your work table. So we recognize that 24 times 10 is 240. 24 times 20 is 480. This is the same as the multiples of 10 chart that we made at the bottom of the left page. So we know that 768 is somewhere in here. So it's somewhere between 30 and 40. So we know that the answer, or the quotient, is going to be between 30 and 40. That's using the estimation model. Now, again, I'm going to revisit the area model so that you can see just one more time how to do an area model. You set up your first rectangle with your dividend in the inside, your divisor on the outside, and then your quotient will be the number at the top. Then you draw your second rectangle and you break it into two parts for your partial quotients. And then before you start, you're going to say, how many times does 24 go into does 24 go into 768 without going over? So we look up here and we go, okay, 24 times 20 is 480. 24 times 30 is 720. And then 24 times 40 is 960. Oh, well, 40 is way too high because 960 is bigger than our dividend. So we know the most it can go in is 30 times. So 24 times 30 equals 720. We put our 30 up top as our first partial quotient. 30 times 24 is 720. We write the 720 underneath our dividend, and then we subtract to find our remainder. That remainder then goes over into the next rectangle. So our first partial quotient is 30. Then we're going to see how many times does 24 go into 48. Well, we know that 24 times 2 equals 48. So we're going to write our next partial quotient as 2 up in the quotient above the box. 2 times 24 is 48. We're going to write 48 here, subtract, we have no remainder. So our quotient is going to be 30 plus 2, or 32. So that is how you use a division area model. We're going to go on to page 89. So in the first modellet, how do you know the quotient is between 30 and 40? So we know that it's between 30 and 40 because 768 is between 920 and 960. So therefore, we know it's going to be between 30 and 40. Looking at the second modellet, the number 24 is multiplied by which estimate? So do we multiply 24 by 30 or 24 by 40? That's what we're trying to figure out to start the area model. Why do you think the other number was not used? So why did we decide to use 30 instead of 40? I want you to pause the video and write that down right now for number 2. Okay, we used 30 and we didn't multiply by 40 because 960 is way too high. If we had used 40, we couldn't do 768 minus 960 because 960 is bigger than 768. So that's why we needed to use 30. What does the expression 30 plus 2 above the area model represent? The 30 plus 2 are the number of buses in the building. So 30 plus 2 is our quotient, or 32 buses. Explain why the numbers 30 and 2 can be called partial quotients. Remember I told you that when we solved here, that was our first partial quotient, and this is our second partial quotient. Why do we call those partial quotients? Go ahead and write that down now and pause your video. All right. Each partial quotient is part of the answer. When you add them together, you get your quotient. So this is just part of the answer, and this is the other part of the answer, which is why they're called partial quotients. So, explain how an area model can help you break apart a division problem and make it easier to solve. Go ahead and tell me why you think an area model makes this problem easier to solve. What I think is that in the first rectangle, we can see what we're doing. So here we can see what we're doing. In this part, instead of trying to find out immediately how many times 24, how many times 24 goes into 768 exactly, we're going to use a number that we know. So 24 times 30 is 720 using our multiples of 10 chart. And then we take our remainder and put it into the next. And then this number over here is much easier for us to do because we know that 24 plus 24 is 48, so we can do that here. So the idea is that it's taking the problem and breaking it up into easier parts. So now I want you to look at the strategies. And so did you like their estimating or the area model better? And then why? If you haven't finished, go ahead and pause your video, and otherwise go ahead and turn to page 90. So now number 7 says, in the problem on the previous page, 768 divided by 24, you first estimated and then used an area model to find the quotient. Describe how you can use multiplication to check that you have the correct quotient. We know that 768 divided by 24 equals 32. We just learned that on the last page. We can multiply to check our work. Show your work for the check. So right now, I want you to go ahead, pause the video, and do 32 times 24. All right, I'm going to use the standard algorithm to multiply 32 times 24. Here's what we do. 4 times 2 is 8. 4 times 3 is 12. Then I need to add my placeholder 0 because this 2 is not talking about 2 times 2, it's 20 times 2. So if we put that 0, that makes sure that we know that we're talking about 20 and not 2. So that makes this the 20. So now we can do 2 times 2 is 4. 2 times 3 is 6. And then we can add the 2 together. 8, 6, 7. Oh, good. We were right. We got 768. So therefore, we know that 32 is the correct quotient. Now let's move down to number 8. Dante has 468 cards in his sports card collection. He buys cards in packages of 12. Complete the table and give an estimate for how many packages of cards Dante has bought. So we know that this is how many number of packages we have in multiples of 10, and then the number of sport cards. We know that there are 12 sport cards in a pack. So we're going to use 12 to multiply times our multiples of 10. So 12 times 10 is 120. 12 times 20 is 240. 12 times 30 is 360. 12 times 40 is 480. And 12 times 50 is 600. Wait, you didn't stop me. That's okay. We wanted to fill out the whole multiples of 10 chart. Now we need to look and go, okay, we have 468 cards. Where does 468 fit in on this multiples of 10 chart? That's right. It fits in right about here. That's where 468. So it's between these two values, between 360 and 480. So now we need to know about how many packages would we need of sports cards. We would need about, I'm going to say between. I like between better. So we would need between 30 and 40 packages. Now let's look at number 9. Refer to the situation in problem 8. Complete the area models to find the quotient of 468 divided by 12. How many packages of sports cards did Dante buy? So I want you to go ahead and do this by yourself. Pause the video, use this multiples of 10 chart to help you fill out the rest of your area model. As soon as you're done, you can start the video back up and see if your answer matches what I came up with. So go ahead and pause the video now. All right. We know that we have a dividend of 468 and a divisor of 12. We carry that divisor over here, and our 468 dividend goes in the middle here. Now, the first thing we need to do is how many multiples of 10 does 12 go into 468 without going over? If we come up here, if we get all the way up to 480, it's too big. We've gone over. So we're going to stop at 30 packages. So we're going to write our partial quotient of 30 on top. Then 12 times 30 is 360. So then we're going to say, okay, what is 468 minus 360? They did the math for you, and they put the 108 as your remainder. Then we're going to take that remainder and move it over. Now we're trying to find out how many times does 12 go into 108. So to find out how many times 12 goes into 108, go ahead and look at your multiples of 10 chart on your Avid binder. You should find what 12 times what is 108. All right, I hope that you found it, but 12 times 9 is 108. So we can write our 108 here. We subtract, we see that we have no remainder. So now we have our second partial quotient. So then when we add 30 plus 9, we get 39. So our answer of exactly how many sports cards packages Dante bought. Dante bought 39 packages. And with that, we're done with our math for today. Tomorrow, we'll be doing that partial quotients method that I brought up earlier today. I got ahead of myself. But so today, during your practice, you're going to be practicing using area models just a little bit more, and then we'll give you some more tomorrow.